On August 25, 2012, something subtle happened far beyond Pluto. A signal from a spacecraft called Voyager didn't just keep going outward. It changed. The particles hitting it were different. The space around it behaved differently. After 35 years of travel, Voyager had slipped out of the Sun's influence and into interstellar space. What makes this strange is how unceremonious it was. No visible line, no dramatic edge, just numbers quietly shifting on instruments built when slide rules were still common. Scientists didn't even realize what had happened right away. It took months of checking and rechecking the data before they were willing to say it out loud. This was the first time anything made by humans had reached the space between stars, and it didn't look like what textbooks had prepared us for. The boundary of the solar system wasn't soft or gradual. It was abrupt, almost defensive. Voyager found itself in a region where particles from the Sun dropped sharply, while high-energy particles from the galaxy flooded in. The Sun's influence didn't gently fade. It hit a kind of wall. That discovery forced scientists to rethink what it even means to live inside a star's domain. Our solar system isn't just a collection of planets orbiting the Sun. It's wrapped in a vast, invisible structure shaped by solar wind and magnetic fields, pushing back against the galaxy itself. Voyager didn't just leave home. It showed us that home has borders, and those borders are far stranger than we ever assumed. For decades, scientists pictured the edge of the solar system as something hazy. The Sun's influence was expected to thin out slowly, like light fading at dusk. Solar particles would become less common. Interstellar space would gradually take over, and there would be no clear moment where one ended and the other began. That idea came from models, not measurements. Before Voyager, no spacecraft had ever gone far enough to test it. Everything beyond the outer planets was educated guesswork. The Sun constantly blows a stream of charged particles outward called the solar wind. That wind creates a giant bubble around the solar system, known as the heliosphere. The assumption was that this bubble would fray at the edges, mixing with interstellar space over a vast distance. Voyager showed that assumption was wrong. Instead of a smooth transition, the data pointed to a sharp boundary. Solar particles dropped off dramatically over a relatively short span of space. At the same time, particles that originate from distant supernova and other stars surged in. It was less like drifting into the ocean and more like stepping through a doorway. This mattered because it changed how scientists think stars interact with their surroundings. The Sun isn't passively sitting in the galaxy. It's actively carving out a protected region, holding back the constant rain of high-energy radiation that fills interstellar space. The solar system, it turns out, is not an open neighborhood. It's enclosed, and that enclosure is far more defined than anyone expected before Voyager touched it. Voyager didn't cross the edge of the solar system with a single unmistakable signal. There was no instrument that flashed interstellar space. Instead, the evidence came in pieces, and each one told a slightly unsettling story. One of the clearest clues came from particle detectors. For years, Voyager had been swimming in particles launched by the Sun. Then, over a short period of time, those particles almost vanished. At the same moment, a different population surged in. These were high-energy cosmic rays that don't come from our Sun at all. They come from distant stars and violent events across the galaxy. That alone suggested Voyager had entered a new environment. But scientists were cautious. Solar activity rises and falls. Maybe this was temporary. The real confirmation came from the plasma around the spacecraft. Inside the solar system, the solar wind has a certain density and pressure. Outside it, the properties are different. Voyager couldn't directly measure this at first. One of its key instruments had failed years earlier. Then, in 2013, a burst of activity from the Sun sent shockwaves rippling outward. When that disturbance finally reached Voyager, it made the surrounding plasma vibrate. By listening to those vibrations, scientists could measure the density of the space Voyager was in. It was unmistakably interstellar. The numbers didn't match anything seen inside the heliosphere. Voyager hadn't just moved farther out. It had crossed into a different regime of space entirely. What stunned researchers most was how narrow the transition seemed to be. This wasn't a vast borderland, it was a boundary. And once Voyager passed it, there was no ambiguity left about where it was. a magnetic wall between stars. One of the most unexpected discoveries came from Voyager's magnetic readings. Scientists assumed that once the spacecraft crossed the edge of the solar system, the Sun's magnetic field would give way to a completely different one from interstellar space. A clean break. One field ends, another begins. That is not what happened. Voyager saw the strength of the magnetic field jump, but its direction barely changed. It was as if the Sun's magnetic field had been stretched and pressed flat against an external force, forming a compressed layer rather than snapping away. This region is called the heliopause, and Voyager revealed it behaves more like a magnetic wall than a foggy boundary. On one side, the solar wind dominates. On the other, the galaxy pushes back with its own charged particles and magnetic pressure. That wall does something important. It blocks many of the most dangerous cosmic rays from freely entering the inner solar system. These particles move at nearly the speed of light and can damage DNA, electronics, and spacecraft systems. Inside the heliosphere, their numbers are much lower. Just beyond it, Voyager measured a sudden spike. In other words, our planetary neighborhood sits behind a kind of natural radiation shield. This discovery changed how scientists think about habitability on a cosmic scale. The Sun isn't just providing light and heat. Its magnetic influence creates a safer environment, one that may have played a role in allowing life to persist on Earth for billions of years. Voyager showed that the space between stars is not empty or gentle. It is active, energetic, and constantly pressing in. And the only thing holding it back is a magnetic structure we never knew was so sharply defined. Voyager's crossing didn't just redraw the edge of the solar system. It gave scientists their first real measurements of interstellar space itself. Before this, everything we knew about the space between stars came from telescopes and theory. Now we had instruments sitting inside it. One surprise was how active interstellar space turned out to be. It isn't a calm void. It's filled with fast-moving particles, tangled magnetic fields, and constant pressure from the wider galaxy. The solar system is moving through this environment at tens of thousands of miles per hour, and the heliosphere is shaped by that motion. This matters for future spacecraft. Any probe sent toward another star will have to pass through this boundary and survive what lies beyond it. Electronics, shielding, and communication systems all need to account for higher radiation levels and a very different plasma environment. It also matters for planets around other stars. If a star's magnetic bubble is weak or unstable, its planets may be far more exposed to cosmic radiation. Voyager's data suggests that stellar magnetic shields could be a major factor in whether a planetary system is friendly to life or constantly hostile to it. Perhaps the most humbling part is scale. Voyager has been traveling for more than 4 decades. It has only just stepped outside the Sun's influence. Even now, it is still deep inside the galaxy's backyard. What Voyager taught us is that leaving the solar system doesn't mean reaching something simple or empty. It means entering a much larger system with its own structure, forces, and rules. And we've only just crossed the front door. Voyager was never meant to do this. It was built to fly past a few planets and keep going until it went quiet. Instead, it ended up answering a question no one could test when it launched. Where does the Sun's world actually end? The answer turned out to be more concrete than expected. Not a slow fade into darkness, but a real boundary shaped by pressure, motion, and magnetic force. A reminder that even on scales that stretch for billions of miles, structure still matters. There's something fitting about how this discovery happened. No cameras, no live broadcast. Just a faint radio signal traveling for over a day to reach Earth, carrying evidence that our assumptions were off. Voyager didn't find something dramatic. It found something truer. And it's still going. Long after contact is lost, Voyager will keep drifting through interstellar space, carrying a record of where it came from. A quiet proof that curiosity can outlast the tools that built it.